In this first problem, we're going to be looking at a proportion that's been set up representing two similar polygons where one's missing a side. So notice, right, we have two values here, and we have a value here, and then we have a variable. So this is a very common problem, and just to refresh your memory on what to do when you get one of these, is we're going to use what we call the cross multiply method, which basically just means we're using inverse operations, right? Taking this denominator and multiplying it to each side of the equation to move it over. But I think when you're looking at these, and you're doing a lot of them, it's real easy to just cross multiply, which is the same thing. So in other words, we're going to do 5 times 90. And you're going to see me, I'm going to write this on different sides of the equation. And then we have this x right here being multiplied to this 20. So x times 20. Notice as I crossed it, I wrote it out so you can see what we're doing. And then I'm going to take 5 and multiply it to 90. So if I do 5 times 90, it's going to give me 450. And then x times 20 just becomes 20x. Now from this point, right, it's just a one-step equation. And what we want to do is we want to get rid of this coefficient in front of the x. The way we get rid of a coefficient is we do the inverse operation, which is basically dividing. So I draw this bar here representing division, and I put my 20 underneath. But to keep this balanced, I also need to divide by 20 on the left side as well. Now 20 will go into 20 one time, so we like to say that these cancel, or they really just become 1, and that leaves us with just 1x. And then 450 divided by 20, I'm going to put that in my calculator, 450 divided by 20, notice it gives me 22.5. So this value becomes 22.5, and we are done. That is the answer to this equation. Now in this second example, notice it looks a little bit different, right? Because instead of having a number in 3 spots and 1x, notice we have this expression 12 minus x taking the place of one of the sides of a polygon that this was created from. We're still going to treat it the same way. We're going to cross multiply. So for instance, I'm going to go ahead and start by multiplying this one that looks a little bit more complex. I'm going to multiply 12 minus x times 3, and if you're wondering how to do that, you're simply going to use your distributive property and put parentheses to make sure you don't forget to distribute the 3 to the 12 and the negative x. In other words, if I were to multiply this out, I'm going to go ahead and take that 3 and multiply it to the 12 and then the negative x and write those values beneath. But before I do so, let me go ahead and set up the other side. On this side, we're going to be multiplying x and 1. So x times 1. Now I'm going to go ahead and distribute right quick. We have 3 times 12, and 3 times 12 will give me 36. And we have 3 times negative x, which will give me negative 3x. And that's all going to be equal to simply x over here on the right side. Now from this point, I want to go ahead and move my x away from the constant. And normally I have you move the constant to the right and the variable to the left. But in this case, since the constant and the variable is over here on the left, I really just need to move the variable over. So I'm going to add 3x because that'll let this 3x cancel, right, and become a 0 set. Now to keep it balanced, I also have to add 3x to the other side of the equation. And if I have 1x and I add 3 more x's, that leaves me with 4 x's. I'll simply bring down my 36. And now I want to go ahead and divide out this coefficient before x of 4. And I want to do that on both sides to keep it balanced. 4 going to 4 one time, leaving me with just 1x. And 4 will go into 36. 9 times. So in this case, x is equal to 9. And there's your refresher on how to solve for x when given a proportion representing two similar figures that are missing a side.